So, good morning everyone. Now we are going to see about the topic named as limit cycle oscillation. So, in this we have two types. One is zero input limit cycle oscillations and overflow input limit cycle oscillations. So, let us see one by one. So, first we have to see the topic named as zero input cycle limit oscillation. So, in this we have detail explain we have detailedly know about what is the deadband, what is the need of the deadband. Okay, first let us move on to the topic. So the limit cycle that occurs as a result of quantization that affects multiplications. So the amplitude of the output during a limit cycle that are confirmed to a range of value that is called as deadband of the filter. So now let us see the deadband derivation. Okay, let us consider the IR filter difference equation. As we all know that y of n, which is equal to x of n plus alpha into y of n minus 1. So let us assume that the x of n value should be 0.875 for n is equal to 0. Otherwise we can put 0. So let's take the first condition, that is for n is greater than or equal to 0, that y of n minus alpha into y of n minus 1 plus x of n, that alpha into y of n minus 1, which is considered as a product term. Okay, so after rounding the product term, the equation must be yq of n, which is equal to q into alpha y of n minus 1 plus x of n. Then during the limit cycle oscillation, the q into alpha of y into n minus 1, which is equal to y of n minus 1 for alpha greater than or equal to 0, and minus y of n minus 1 where alpha which is less than 0. With rounding, the equation must be defined as minus q by 2 less than or equal to en less than or equal to q by 2, that e of n which is equal to q of n minus sorry x of q of n minus x of n. Okay, now e of n should be written as q into alpha y of n minus 1 minus alpha into y of n minus 1. So this equation which is derived from with this equation, which becomes from the above equation, we got to substitute the value of xq of n and x of n. The After that only this equation will arise. Okay, now by the definition of rounding, we can write the above equation as modulus of q of alpha into y of n minus 1 minus alpha into y of n minus 1, and then q of and then the above equation can be written as modulus of q into alpha y of n minus 1 minus alpha into y of n minus 1. This is less than or equal to 2 minus 2 power minus b divided by 2. So let us take this as equation 2. So now substitute the equation 1 in equation 2, then the equation really becomes y of n minus 1, which is equal to x into y of n minus 1, which is less than or equal to 2 power b by 2. Then the modified equation, which can be written as y of n minus 1, which is equal to 2 power minus b by 2 into 1 minus modulus of alpha. This is called as deadband equation. Now let's get into the problem. The problem which have been given is explain the characteristics of LCO and write to the system. It is destined by the difference equation, that is y of n, which is equal to 0.95 y of n minus 1 plus x of n. Determine the deadband of the filter. So like this question we have given. So first assume that here x of n should whereas not given, so we can assume that the x of n must be 0.875 for n is equal to 0 and 0, otherwise sorry. Now let us take the number of bits which is equal to 4. Let us assume that the number of bits equal to 4, excluding the sign bit. We don't include the sign bit, so we need to exclude it. So let us consider the number of bits, that is n is equal to 4. So let us take the y of n minus 1 is equal to q into 0.95 y of n minus 1 plus x of n. Okay, for let us substitute for n is equal to 0. Then substitute in the above equation, means it becomes y of 0, which is equal to q into, so put n is equal to 0. That means 0 minus 1, that is minus 1. So that is y of minus 1 plus x of 0. Here y of minus 1 should be 0, because the limit for n is equal to 0 only 0.875. so otherwise we can assume that it will be 0, so that the y of minus 1 in the place we have to insert the 0. Okay, let it be that is 0 plus 0.875. so y of 0 value should be 0.875. Okay, let us take the next for n is equal to 1. So we can substitute the n is equal to 1 in the above equation, that is y of 1 which is equal to q into 0.90 into y of 0 plus x of 1. So we can substitute the y of 0 in this equation, so that 0.95 into 0.875 plus x of 1. Here in this limit we have seen that otherwise we can assume that it is 0. For 0 n is equal to 0 only, that is value should be 0.875. Otherwise we can assume that it is 0, so that x of 1 we can assume it is as 0. Okay. Then multiply these two, we get the equation that we get the value, that is 0.83125. So now it is in the decimal format. We should convert into binary, so that we can multiply with 2, that is 0.8312 into 2, that is 1.66. Then take the last two values, and then multiply again with 2, that is 1.32, and then take the last two values and then multiply with 2, then take last two values. Likewise we have to multiply each by each value. So after stage, once after stage, we can take the first 4 bit of first 4 bit we should take, and that is first 4 bit can be taken as 1101010. Here the values which are being obtained for us are 1101010. Okay. Now rounding off, that is b which is equal to 4. So let us consider only point after, that is only 4 bit only should be considered. So let us take the first 4 letters, that is 1101. That's only here is taken as 1101. So now here is a binary, so we should convert it into decimal. So decimal in the sense 1 into 2 power minus 1, point after that is should be considered as 2 power minus 1, 2 power minus 2, 2 power minus 3. So that is we should be considered, that is 1 into 2 power minus 1 plus 1 into 2 power minus 2 plus 0 into 2 power minus 3 plus 1 into 2 power minus 4. So let us now we have converted into binary from decimal. Okay. So sorry, now we have to now we have converted the binary value to decimal. Okay. So we can substitute that n is equal to 2, so that y of 2 which is equal to q into 0.95 plus into y of 1. So now we have substitute the y of 1, that is decimal value, in this equation. So that x of 2, here x of 2 already know that we should obtain 0 only. Now 0.95 into 0.8125, now that decimal value which has been obtained, which is converted into binary, so that the binary which has been obtained here. So let us take the first 4 bit only, that is 1100. Here 1100 only should consider, and the binary values which are get obtained, then we should convert this binary to decimal again, once again, so that 2 power minus 1, 2 power minus 2, 2 power minus 3, 2 power minus 4, so that the decimal value should be obtained here is 0.75, that is y of 2. Then put n is equal to 3, so that q of 0.95 into y of 2 plus x of 3. So we know that x of 3 should be 0, and y of 2 value that we have find the before, that substitute the value in this equation, that is 0.95 into 0.75. So we should multiply these two values and we get the value as 0.7125. Then here it is being decimal value converted into binary, so that multiply with 2, the binary value which get obtained here, that is 1011011. Okay. So first we have to take only 4 bits alone, so that is we have to take us 1011. Here it is to be as binary, we should convert to decimal, so that 2 power minus 1, 2 power minus 2, 2 power minus 3, 2 power minus 4, so that it can be converted into decimal, so that y of 3 which is to be as y of 3 which is equal to 0.6875. Then we should be considered that for n is equal to 4, so the substitute in the equation, that is y of 4 which is equal to q into 0.95 y of 3 plus x of 3, 0. Then y of 3 value should be mentioned here, so that the value should be must be written in this equation, and then multiply these two values and get the resultant value as 0.653125 plus x of 3, as we all know that it should be 0 alone, so that here the decimal value should be converted into binary, so that should be converted into binary means the binary value is obtained is 101001. So let us consider only first 4 values alone, that is 1010. Here they are binary, then converted into decimal, so that 2 power minus 1, 2 power minus 2, 2 power minus 6, value obtained here is 0.025. 0.0625. Okay, so let us take for n is equal to 5, then substitute in this equation, that is y of 5 which is equal to q into 0.95 plus y of 4 plus x of 4. As we all know that x of 4 which is should be 0, and then y of 4 we have find in the before equation, that substitute in the substitute the y of 4 value in this equation, so that 0.95 into 0.625, so multiply these two values and get the resultant value as 0.5935. so here it is in decimal form converted into binary, so that the value should be obtained here is 10011. so let us consider only 4 values alone, so that 1001 um, now it can be converted into now it can be converted into decimal again, so that 2 power minus 1, 2 power minus 2, 2 power minus 3, 2 power minus 4, so that is the decimal value which has been obtained here is 0.625. so now we can write the deadband equation, as we all know that deadband equation which is equal to 2 power minus b divided by 2 into 1 minus k. See here b which is equal bits, number of bits has been assigned is that is number of bits that is assigned is 4, that so only we have mentioned here as 2 power minus 4 divided by 2 into 1 minus k in the sense the constant value should have been given here, that is 0.95. this is to be considered as k value, so that here mentioned here as 0.95. So that is so after solving this equation, the deadband which is equal to 0.625, that is so that the output is constant that n is greater than equal to 4. So thank you.